Hello. Hello, everyone. I'm Kenni Konate, machine learning engineer. I have a master's degree in artificial intelligence and data science. Happy to be with you today to explore multiple linear regression model with Python. So we can start our slides. So what is regression analysis? Regression analysis is a statistical technique for estimating the relationship among variables which have reason and result relation. And we have a simple linear regression model and multiple linear regression model. When we focus on one dependent variable and one independent variable, so here we speak about simple linear regression model. In case of multiple linear regression model, we have more than one explanatory variable, so more than one independent variables. Here we can see the equation for multiple linear regression, and it has the same form of the one for simple linear regression. The difference only about the parameters. So in multiple linear regression model, we have more parameters, as you see here. The dataset that we are going to use here is a dataset collected from various online sources. Actually, is a part of a project that I contribute in with Omdena, and it's an open source project. Yeah, the references for this slides is here. Let's start training our model. Yeah, as you see here, the code is already on Kaggle, which is a platform for data scientists and machine learning engineers. There they share their code, the data sets, and also contribute to different competitions and share their codes, which is open source there. So today I want to train my model there on Kaggle. But we will start from scratch. So here is this notebook is already trained, is already worked, and the model is trained. So that's where we will start from here. Yeah, this one is where we will work. Yeah, we are working here. Yeah, actually from here, we can add the dataset. Of course, this dataset should be already on Kaggle. So from add input here, you can upload the dataset. For example, if I want to upload a new dataset, so I can choose my work dataset. So here I can see more datasets that already is on my account here on Kaggle. So from this, I can add the dataset. But we already have the dataset that we will work on. As you see here. After adding the dataset or uploading it, so here we can import the dependencies, the libraries that we will need. So let's run it. Yeah, let's run it. From here, if we want to, like, we want to read as its CSP format, this dataset is saved with CSV format. So from here, you can copy the path of dataset and add it here, as you see. So let's run this also. Sunny. Now we want to know the shape of our dataset. How many rows we have, how many columns we have. So 65 rows, 45 columns. And if we want to see a little bit about the columns that we have in the dataset, so it will show only the first 5 rows. As you see here, we have different columns in this dataset. Actually, it's a financial dataset. That's why you see the gross, the consumer price, all of them. Yeah. What we have else? Yeah, money supply, bills, even the food imports and the food exports, the percentage of them. Let's see if there is something to mention it here. Yeah, why it's Naira? Because this project was about this set is about Nigeria. So to see the price surge in Nigeria, so that's why there is Naira, the petrol price in Naira, as it's written here. Here we have the GDP, gross domestic product, as you see. It's one factor to know the economy health in a country. Here it's from 16 to 2024. Yeah, 2024. Here we can print the last year. We can run it. Normally it should be run it, but no. Why it's not just run here? That's no problem. We can see the output here. So as you see, it's from here. The dataset is from when we talk about the year, it's from 1960 to 2024. Here to see the information about our data. So here, as you see, can see more information about also the column's name in details, data type, even the memory usage. Here is now to check the missing values. So as you see here, we don't have the missing values in our dataset. Let's see if we can run it again. Of course, from here we can run all of this, but I would like to run it one by one. So run the current cell. Yeah, okay. It runs now. Here with the describe, we see the statistical measure about the data. So the count, the mean, the standard, minimum, and as it starts from 60, you see here. So it's written 1960, and the max is 2024. Here about the target variable. So the target variable is the gross domestic product per capita with US dollar. So it will be the target variable. As I said, it's a factor to know the economy, the health of economy in a country, if it's good or not. And here also we want to know the price surge in this country. Okay, let's run this one also. As you see, yeah. Here we will start splitting the features and target. So the target is, we drop the X here. So from all the columns, we drop the GDP per capita column to be our target variable. So we drop it from the other columns and add it here to the Y column. So in the X, we still have the other columns. Let's see, as you see here. So in the Y, we will have the target variable. As you see here. Yeah, the name is GDP per capita, current US dollar. So before training our model, we split the data to training data set and test data set. With this code, we give 20% to the test dataset and the 80% to the training dataset. So let's run this code also. Yeah. After splitting the data, here we can see how many columns and rows we have in each data set. Let's run this one. So in total, we have 65 rows for G3, because before we have 44, but one now is a target variable. So we still have only 43 columns in total. In the training dataset, we have 52, and in the test dataset, now we have 13 rows. Let's run this one. Yeah. Here we go to the training, model training. So we choose linear regression. As I mentioned it before, that in simple and multiple and simple linear regression model, the only differences is in the parameters. So that's why here we only choose linear regression, not so written simple or multiple. So from here we choose the model. Yeah. And of course, it's not registered, but linear regression model. Because before in one session, we train logistic regression model, I think so, with hard disease dataset. Yeah, let's run this one. Yeah. So with fit, we train our model. And he will make the prediction with test dataset. You can see here the output. After that, we go to the evaluation metrics. So in regression models, we have different evaluation metrics. So we have R-squared score, mean squared error, root mean square error, and mean absolute error. And here, I think I used all of them. So let's see, to evaluate the performance of our model from here. This is mean absolute error. Let's run it. The output will be shown here. Yeah. For the mean absolute error, as it's too small, that means that the prediction is more better. So here we have 0.05. Mean absolute percentage, let's run it here. Also the same. Here we have mean squared error. The output is here. As you see, the value is too small, which is better for our model performance. Here the R square, which is the coefficient of determination. Let's run this current and see the output. Yeah, as you see here. Here we have root mean square error. As you see here, we use it with NumPy because it's only the square of mean square error. So we just use NumPy square here. Like manual. There is another. Yeah, maybe because I think that this one. Yeah. I think that you get why we used NumPy here, as I mentioned. And here we're plotting the results with the comparison between the prediction and the actual values. So let's run this. Yeah. Yeah. As you see, Y test is the actual values. Here, Y prediction, the predicted values. So as you see here, like there is no difference between both. Like there is overlapping between them. So that means the prediction, it's well predicted. So like there is no difference between both of the both values. Yeah, that's it. I think I mentioned the most important points about the multiple linear regression model. I wanted later, if I will have a session, to explore more the evaluation metrics in more details, like the mentioned evaluation metrics in regression models, like the R square, mean squared error, root mean square error, mean absolute error. Those all. Yeah, as I mentioned from here, you can, yeah. Actually, if you have any question, I'm ready to answer them. Otherwise, we can finish this session and until we will meet in another one. So thank you so much.